Hey guys, welcome back to another video. If you're new to the channel, I do a lot of GCSE Maths and Science content, as well as A-level Maths and A-level Physics as well. So if you are new to the channel, please do consider subscribing. Also in the description, I have a link to my email address if you want to ask about my tuition classes that I offer, or if you want to ask about any other questions or give suggestions or anything like that. Now, in this series of videos, we're going through literally every single GCSE Maths past paper. I'm also going to do GCSE Science for those of you that are interested, as well as A-level Maths for the future of you guys. And we're just going to go through literally every single paper, every single question. I'm going to explain exactly how you get the marks, exactly where people go wrong, and how you can kind of approach different styles of questions, because it's not just topics that people get wrong, it's also the structure of the exam question, the problem solving itself. So without further ado, let's jump straight into the first question of 2023 paper 1. So, dividing decimals, believe it or not, a lot of people do get this slightly incorrect. There's a few ways that you can do this to make it easier for yourself, but I think in this question, the easiest thing for us to do is basically just to get rid of the decimals on both sides. Now, when I say that, we want to actually be mathematical about this. When I say get rid of the decimals, what do I mean? Well, I'm going to times the first one by 100 and the second one by 100. So, I get 846 divided by 15. Which I can just do using the bus stop method. It's a little bit annoying because it's quite a big number, but it's doable, right? 15 into 8 obviously is 0, carry the 8, so 15 into 84, well, I mean, it doesn't go into 90, well, so 15, 30, 45, and then keep going up, so then we have 60, 75. The next number will be 90, so that's too big, so it's going to be 75, that's 5 times, remainder 9. So 95, so that's 96, which is going to be, it goes in 6 times with a remainder of 1. So because we have a remainder, we're going to put a decimal point. So again, it goes into 96 times with a remainder of 6. Because we have no more numbers, we need to add a decimal point. So I'm going to put a 6 there. And then 15 into 60 is 4. So we get the answer of 56.4. Now, something that a lot of students do get wrong is they're not sure if you need to put the decimal point back in. So do I need to divide it by 100? The answer in this case is no, because we times the first number and the second number by 100. So let's say this, for example, right? If I do, let's say, I don't know, 4 divided by 2, obviously that's 2. If I times just the first number by 10, I get 40 divided by 2, which is 20. So the answer is 10 times bigger, right? Which makes sense. However, if I do 40 divided by 20, where I've times both sides by 10, I still get 2. So you only have to divide it if you times the first and the second number by different values. That's the key thing there. So subtracting fractions, but it's improper. Now, I'm going to do this in a very specific way. I'm going to change it to improper fractions first, because that always works. Now, when you're adding mixed numbers, or even subtracting, there are cases where you can get away with not changing to an improper fraction first. But you have to be really aware of when that is. Because if I subtract these two, you could do 7 take away 2, which is 5. But 3/8 take away a half, you can't do. So you'd have to borrow 1 from the 5 as well. So that's where people get a bit confused. So instead, I'm just going to change this into an improper fraction. So first thing I need to do, 7 times 8, because that's 7 wholes. And each of our wholes is out of 8. So in total, we have 7 times 8 parts. So that would be 56. Add the 3 extra parts we have, so that's 59 over 8. Again, we have 2 wholes and they're split into halves, so 2 times 2 is 4. Add the extra half we have, so that's 5 out of 2. We have 5 halves in total. That right there gives you a mark, which is really, really nice. Now, how do you subtract fractions? When you're adding or subtracting, you have to make the denominator the same. So I'm going to make this right denominator, I want to make it into 8, because that's probably the quickest thing to do. And times both by 4. So we get 59 over 8. Take away 20 over 8. And now all you do is you subtract the numerators, not the denominators. 59 take away 20 is 39 over 8. And it's requesting that we do it as a mixed number. So how many 8s go into 39? Well, 8, 16, 24, 32. The next one's 40, that's too big. So it's 32, it's going to be 4. And what's the remainder? Well, if I'm at 32 and I want to get to 39, I have a remainder of 7. So 4 and 7 over 8 for another 3 marks. So it's really nice marks that you can get, but people do make mistakes on them. Now getting into the first kind of problem-solving question that some people may not have come across. Now, a problem that I have with some students that are very clever is they're very clever and so they don't get much exam practice because they find the work very easy. Then they come across something like this and it's hard for them to work out what to do. So a cube has a total surface area of 150 centimeters squared. What's the volumes? First thing I would do is I would draw out, as best I can, a cube. Now, again, please... Oh, come on. That was better before. What are you doing, Microsoft? You're killing me here. Something like that. Now, if we think about what surface area is, it's when you add up the areas of all of the faces, and the cube has 6 faces, right? So there's 6 of these faces that it has, and we'd add them all up. Okay, now does that really help me? Well, if it was a cuboid, it wouldn't help me because all of the faces will be different, right? We'd have different lengths, so the front face won't be the same as the top or the side. But because this is a cube, what's special about a cube? It means all of the sides are the exact same length. So again, when you're approaching this, draw it out, think about what they've given you, what it means, but then also think about what they're asking you to work out. They're asking me to work out the volume, which is all 3 lengths multiplied together. Now the only way to do that is to work out all 3 lengths. That's impossible if this wasn't a cube. So the fact that it's a cube is very important. So our end answer is just going to be x cubed, which is nice. So how do we work that out? Well, the surface area is 150, so I could work out how much one face is worth. One face, because all of the faces are equal, is just equal to 150 divided by 6. Okay? So again, that's the first thing you need to think about. Now, so 20 would go to 120, so it would be 25 centimeters squared. So let's say this front face is 25 centimeters squared. All of the faces are. But then to get x is just going to be the square root of that, right? Because how do we get the area of the front face? We do x times x, we do x squared. So if x squared is 25, then x is the square root of 25, which is 5. So now lastly, the volume is just x cubed, right? So it's just 5 cubed, which is 125 centimeters cubed. 4 marks. So again, the maths isn't difficult, right? Working out these calculations isn't hard, but knowing what to do is the tricky bit. The table shows information about daily rainfall. It gives us this table, which is a grouped frequency table. It's grouped because we have these class widths, and it's frequency because it gives me the frequency. Shocking, I know. Draw frequency polygon. Now, the biggest problem with frequency polygons that I've come across is students confusing it with a cumulative frequency diagram or even a histogram. So I've had students draw histograms for this because they see frequency and they just kind of, their brain auto fills in frequency density. And so they draw a histogram. The problem is you can actually draw a histogram with this. Like, it's completely possible to draw a histogram because it's the same information you need for a histogram. And likewise, you can also draw a cumulative frequency graph because you have the information required for a cumulative frequency graph. But it doesn't give you the marks, and that's the problem. So, what do we do? A frequency polygon is where you plot the midpoints of the classes. So that would be 2.5, 7.5, 12.5, 17.5, and 22.5. And the frequency. That's it. That's literally it. So what some people do is they plot the highest value, so 5, 10, 15, 20, and they just do the cumulative frequency, or they draw a histogram. So that's the mistake people make. So it's not exactly difficult, just people forget what to do. So 2.5 and 8, 2.5 would be, so in fact let's zoom, 2.5 would be right in the middle, and 8 would be 2 from the top. And there's another difference, which I'm going to show you in a second. So 7.5 and 24 would be right below here. Always check if it's actually going up in ones, by the way. So how do I know it's going up in ones? Well, between 20 and 30, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So it's 10 squares, and it goes up in 10 by 10. 10 divided by 10 is 1. Same with the width, right? This goes up 10 squares, but the actual value only goes up by 5. 5 divided by 10 is 0.5, so each of these is 0.5. The next one is 12.5 and 13. Yep, 12.5 right in the middle, and 13. So 1, 2, 3 right there. 17.5 and 11 goes there. 22.5 and 4. Now, here's the next thing that people get a bit wrong, is how do you join these points up? Now, they actually do this wrong in a cumulative frequency graph as well. With a cumulative frequency graph, it's more of a smooth curve. in a frequency polygon, well, polygon, right, it's a shape, you need to join them with absolutely straight, jagged lines, like you're drawing a mountain range in geography or something. As soon as the autocorrect actually works. There we go. So again, we're drawing, like with a ruler, do we connect the dots? Okay. Now, the next thing that people should keep in mind is, do you have to join the first and last points? Now, on the internet, it's a bit confusing because it's a polygon, right? So it should be a shape. So in theory, we should actually connect the first and last points. And you do see that online quite a bit. But in the mark schemes, you actually don't have to. So yeah, keep that in mind. The other thing that people mistakenly do is they draw a line from 0 to the first point. That only happens in a cumulative frequency graph. It does not happen in a frequency polygon, okay? So do bear that in mind. So here is sets, which again, some students just don't really remember what a set is, which is fair enough, I suppose. But the biggest mistake I see is not writing out all of the values in each of the sets here. So what do I mean by that? Well, sometimes this thing here, which is the set of all numbers, it will tell you, oh, it's all of the numbers up to 20. And people miss some. So what I would do is I would write out every single number. I'd write out the numbers from 1 to 20. That's what I do all the time, so you don't make a mistake. They've done this for us, so we don't have to do that. But for set A, it says odd numbers. Now people, again, they don't write out the odd numbers. I do. So 1, 3, 5, 7, and 9. Only the ones from this set. The square numbers. Well, the square numbers, and this is the mistake people made this year, is they didn't recognise that 1 is an odd and a square number because they didn't write it out. So 1, 4, and 9 are our square numbers. Now we'll have to fill it in. If it's in both of my lists, then it goes directly in the middle. So the 1 goes right in the middle. And what do? I go through and I cross it off. 1. That way, I know I'm finished when I've crossed off every single number in this top set. The next is 3. Well, 3 is not square, so I'm going to write it over here. And again, I'm going to cross off 3 from both of those numbers sets. Next number is 5. That's again not in, it's not a square number, so we don't need to write that. Next one is 7, which isn't a square number, so again, goes just in A. Cross it off. 9 is a square number. So I'm going to, whoa, what am I doing? Is a square number, so I'm going to write it in the middle, and I'm going to cross it off from all 3 lists. Then if I look at B, the square numbers, the only square number I haven't written is 4, so I'm going to put that just in B, cross it off from both lists. Now every number I haven't crossed off, 6, 8, and 10, has to go outside. Now what happens if there are no numbers left over? You would have to write either 0 or none or something. You'd have to write something on the outside. So write none or empty, just to make sure that you haven't missed any. And there you go. 3 marks. You drop a mark for every mistake you make. So if I missed a number, I lose a mark. If I put a number in the wrong place, I lose a mark. This is the freest 3 marks you'll get. So again, it's worth doing this. Now, yeah, find the probability of this number is in this set. I'm going to call it B apostrophe for a second because I don't want to give it away. The apostrophe means not. So we're looking for all of the numbers in the set not B. So that's everything outside this circle. So how many numbers are outside the circle? 1, 2, 3, 4, 5, 6. How many numbers do we have in total? Well, it's 1 to 10, so we have 10 numbers. So we have 1 out of 10. I missed a number 2. There we go. That was lucky. So that would be 7 out of 10 then. Out of 10. For another 2 marks. So again, there's 5 marks. Quite nice. Quite easy. The scatter graph shows information about the ages and weights of some babies. And we get this kind of like upwards trend. Perfect. And it says describe the relationship between the age and the weight of the babies. Now there's a bunch of different things you can say, but in my opinion the easiest or simplest, the shortest thing to say is if it's going up and to the right, you just say positive correlation. If it's going down and to the left, So it's going this way, you would have a negative correlation, and if they're just randomly put, then you say there's no correlation. But other things you could say is you could also say as age increases, the weight of the babies increases. As you get older, your weight increases. Something along those lines also works. Something that some students write is they write positive relationship. That's not accepted. Okay? It's just not. Another baby has a weight of 5.8 kilos. Using the scatter graph, find an estimate for the age of the baby. Here's what you have to do. It's 2 marks. You have to draw a line of best fit. You have to. It is compulsory. Even if you guess the right answer, you'll only get 1 out of 2. So, line it up. By the way, my ruler on this is not the best because it only goes up in like set degrees. It doesn't go up normally. Let's see. Does that look about right? I think that looks reasonable. And we're just going to draw a line of best fit. Boom, like that. And I'm just going to get rid of this. And then it says the weight is 5.8, estimate the age. So we're going to go to 5.8 on our graph. So let's see, so 5 is in the middle. So this goes up in 0.2s by the look of it. 5.2, 5.4, 5.6, 5.8. And we're going to draw a line going across. You can use a ruler for this if you want. Oh, look at that, that's beautiful. Right on an edge of a square. So I can see which one this is. Right there. So that would be 3. I think this also goes up in 0.2s. So 3.6 years. 3.6 years. Cool. Sorry, months. What am I talking about? Years. Cool. And that's it. You do get a range. So the range in the mark scheme was anything between 2.5 and 4.5. So anything between here and here. That's a big range. So you don't have to be super, super accurate because, again, between those 2 points here. But, again, try and draw the line of best fit as best you can. Price of a holiday increases by 20%. This 20% increase adds £240 to the price of the holiday. Work out the price of the holiday before the increase. A bunch of different ways to do this. But the thing we have to keep in mind is whenever we do percentages, again, even some of the clever students that are getting grades 7, 8 and 9s, they rush into it. Read it very carefully. There are 2 things that you can do here, but here's my recommendation. It says the 20% increase adds £240 to the holiday. Now I know that some people use like a bar model, right? Where each of these is like 10%, for example, and then you draw 10 of them. This would be like an extra 2 bars added on the end. But you don't really need to use that. It says this 20% increase adds £240. That means that 20% must have been £240. So how much was the price of the holiday before the increase? So we want to go from 20% to 100%. Now, if you want, you could go down to 10% and then go up to 100%, or you could go straight to 100%. You could do it. You can do whatever you want, really. I'm just going to times by 5 to get straight there. Which means I have to times this side by 5. To times by 5 quickly, you could times by 10 and times by 10 and half it. So that'd be 2,400. So that'd be £1,200. But again, this first step is where people made mistakes, okay? Read the question very, very carefully when you do stuff like that. Because they said 120% equals £240, which is not correct. The diagram shows a solid cylinder on a horizontal floor, and they give us the pressure equation, so we're probably going to use pressure in a second. It has a height of 40, volume of 1,200 centimeters cubed. It exerts a force of 90 newtons on the floor, so we have that F is equal to 90. Okay, cool. Work out the pressure on the floor due to the cylinder. Okay, and remember, pressure is force over area. Now, I only have the force at the moment, so I can't work it out yet. But let's have a look at what else they've given me. They've given me volume and height. So logically speaking, I need to use the volume and height to work out the area. And they've even been nicer in giving us a diagram and labeling the height to make it a little bit more obvious. So my question to you is this: how do you work out the volume of a cylinder? Now, some of you are probably going to give me the equation pi r squared times h. But even more basic than that, a cylinder is a type of prism. And for any prism, whether it's a triangular prism, so it looks like a big Toblerone, or a cuboid, or a pentagonal prism or anything, this is just the area of the face. So either one of these faces, right? So for any prism, it's just the area of the front face times the height or the length, depending on how you want to define it, right? So if I want to work out the area, well, I have volume and I have height. So I could work out pi r squared. I could work out the area, right? By just doing volume divided by height equals area. Because again, pi r squared is just the area. So if I do that, we have 1200 over 40. Now the reason why I mention this method is if this was a calculator paper, what I often see is people work out r from this equation. So they divide volume, 1200, by pi times h, so by 40 pi. Then they square root it. Then they sub it into pi r squared to get the answer. The problem with that is this. One is it won't be an exact value. Your calculator cannot give you an exact value of pi, which means your value of your value for a will not be 30 as it's meant to be. It won't be 30, it'd be like 29.99999 going on for a long time. The second thing is if this was a non-calculator question, which it is, how are you going to do that in your head? You can't. So, now we can work out pressure, because pressure is just equal to the force, 90, over the area, which is 30. I was scrolling down just to check the units, and indeed the units are in newtons per centimetre squared, so we don't have to convert any units. If you're a scientist, then we would normally change that to meters squared, but thank God we don't have to do that in this question. So here we have a drawing of two different graphs. We have 2y is 3x minus 22, and 2 minus 2y is equal to x. And it asks us to use the graphs, I want to highlight that, yeah, to solve these simultaneous equations. The reason why I'm highlighting it is the number of students that I see trying to just add the two equations to eliminate y and then doing all that fun stuff is incredible. You get 0 marks even if you get the right answer. It is actually quite easy to solve using elimination. So by adding the two equations together, you get whole numbers, the answers, but you get 0 out of 1, right? But it is possible. So what are they asking you to do? Well, they're saying use the graphs. Now, logically, when two graphs intersect, their coordinates are the same, right? So at this point here, where these two graphs intersect, the x-coordinate and the y-coordinate are the same for both equations, right? So for example, let's say the x value, so what does it go up in? So 6, 7, 8, 9, 10. Yeah, it goes up in ones. So the x-coordinate is 6, right? That x value is 6 in this equation and in this equation. They're both 6. And the y-coordinate, well, let's read it off. Again, I believe it goes up in ones, right? 1, 2, 3, 4, 5. Yeah, good. So that's minus 2. Okay. If I substitute in x is 6 into here, I'll get y as minus 2. If I substitute x is 6 into here, I'll get y as minus 2. They're the same solution. The reason why I'm making such a big deal about this is I have students even in 6th form, and when they come across things like the modulus or the exponential or some other kind of equation, they don't like sketching graphs to find out the number of solutions. They don't like sketching graphs in order to find the solutions, but it is the easiest way to do things in most cases. So, or in a lot of them anyway. So again, the solutions here are just x is 6 and y is minus 2. You don't need to solve it manually, and if you do, you get 0 marks because it says using the graphs, okay? It's not just about getting the answers, because they're testing to see if you know how to use graphs to solve equations, which is essential if you want to do A-level maths and for certain equations anyway. This type of question comes up all of the time, especially in the recent years. So this is the 2023 paper, came from 2024 and 2025 as well. In foundation, in higher, all of it. Super, super common question. So here's a pentagon. They give you 3 of the angles. Then they give you this. This thing here, they use this not just in angles. They use it in lengths. They use it in trigonometry. They use it in Pythagoras. They use it in percentages. They use it in ratios. They use it everywhere. They use it in solving algebra equations. Everywhere. Because what you need to do for this question, or what I recommend you do in this question, is a skill that is used in almost every single topic. And again, if you guys want to do A-level maths, which I assume a fair few of you watching these videos do, it's just essential. So they're saying the angle AED, they're saying this angle here is 4 times bigger than this angle. Now, what do we do when we don't know a number in maths? We give it a letter, right? We call it a variable. So I can do this in two ways. I could call ABC x, which makes AED 4x, which is nice. But you can also do this. You could call, if you wanted to, you could call this x and this a quarter of x. And you would get the same answer, but for me, I like to keep things in whole numbers. The reason why I wanted to point out that other way is sometimes when I do probability, people get confused as to why I don't use fractions, and instead I use whole numbers. It's because I don't like fractions, right? And I don't think anyone does. And it says you need to work out the size of angle AED. So we need to work out what 4x equals, not x. The number of students that stop once they get x, and therefore they lose that final fourth mark, is incredible. They only get 3 out of 4 because they've worked out x, they haven't worked out 4x. So, how can we work this out? Well, what should the angles in a pentagon add up to? If you're not sure, use the classic equation, n minus 2 times 180. N is 5 in this case, so that's 5 minus 2 times 180. So that's 3 times 180. So that would be 180, 360, add 80 would give me 440, add 100 gives me 540. So they should add up to 540. So all we're going to do is write an equation and solve it. So we're going to add up all of this, so we get 120 plus 135 plus 110 plus 4x plus x equals 540. Let's gather the like terms. So 4x plus x is 5x. So we have 120 plus 135 is 255. Add 110 will give me 365. Minus 365 from both sides. Ooh, okay, so if I minus the 5 first, we get 535. Minus the 60, we get 475. Minus the 300, we get 175. There we go. And therefore x is equal to, so you could divide it by 10 and double it. So divide by 10 is 17.5, double it is 35, if I'm not mistaken. Degrees. Again, some people stop there. But that's not what they asked, right? When you finish a question, whenever you think you're finished with the question, read the question again. What are they asking for? With the probability equations I was talking about earlier, they sometimes ask for the number of blue counters, and people work out x, but they said x was the number of red counters, so they don't get the marks. So AED is 4x, so AED, and this is literally my last line to make sure the examiner knows exactly what I'm doing. So if I double it, I get 70, double it again, I get 140 degrees. Finished. 4 marks, not too bad. A lovely index law question. So again, what I do is I do this in steps. Do not do it in one step. Okay, some people try and do it in one step and they don't get the right answer. Now again, I'm a maths teacher. My GCSEs were 12 years ago, and since then I've done GCSE Maths every single year since then. If I'm doing it, you should definitely be doing it, okay? So what I'll do is I'll do the top first. So it's squared, so I take it literally step by step. I'm not doing 6x to the 5y cubed to the power of 2. I'm doing, what's 6 squared? That's 36. What's x to the 5 squared? Well, that would be x to the 5 times x to the 5. And what do we do when we times two bases with the, two things with the same base? We add the powers. So that become x to the power of 5 plus 5, which is 10. Also, you can literally just times 5 by 2 if you want to. Y cubed, again, that's going to be y cubed times y cubed, which is y to the 6. Now we're going to do the denominator. So again, do it step by step. What's 3 times 4? 12. What's x squared times x? Again, add the powers, so that'd be x cubed. Y to the 7 times y to the minus 3. Again, people think that the rule changes, right? They try and write y to the 10. No. Add the powers. We get y to the 7 plus minus 3. So we get y to the 4. That's 1 mark. Now, all we're going to do is we're going to go through this and we're going to divide it. Now again, we're not dividing the whole thing. Well, I mean, we are, but we take it step by step. What's 36 divided by 12? It's 3. X to the 10 divided by x cubed. Well, when you times two things, you add the powers. So when you divide, logically you would subtract, right? Because they're opposites. So 10 minus 3 is 7. Cool. 6 minus 4 is 2. There you go, 3 marks. Right? Have I left it in the form they want? That's a good thing to check as well. Well, there's a number there. A is an integer, so 3. X to the power of b, where b is an integer. Well, that's x to the power of 7, which, again, is an integer. By the way, this is, I love Microsoft. Okay, there we are. But b is 7, and c is 2. So it's an integer. It's all done. Perfect. Martha plays a game twice. They give you the probability tree on whether she wins or loses, and as you can see, the probability changes, right? Winning the first game changes the probability of winning the second game. Actually, no, it doesn't. I'm lying to you. It's just the probability of winning the second game is different to the first game. It says, find the probability that Martha will lose at least one game. At least. I.e., more than equal to one game. So that means it's either one game or both games. Okay? Keep that in mind. Now, for this question, they do give you 3 marks, which is nice. You get marks for just doing correct multiplications. So you can get marks even if you're not sure what you're doing by just timesing stuff together, which is nice. So, losing at least one game. Okay. So, what are the options here? What are the possibilities, right? What are the different, universes, right? Like Doctor Strange, right? All the different timelines, right? Well, for her to lose at least one game, she could either lose the first game and then win the second game. So she could lose and then win, right? That's one universe, right? That's one possibility. But she could also win the first game and lose the second game. That's still losing at least one game, right? She's lost one. She lost the second game. Again, another universe. She could lose both games. And again, you can probably guess which one some students forgot. It's this last one. At least one game is not just losing one game. It's losing at least one game. So it's 1 or 2 games. I love doing this because now I know, and again, this makes our life so much easier. All we need to do is read the possibilities. Right, once we've got this, life becomes easy. So, what's the probability of losing the first game? It's 3 out of 8. So, cool. And then what's the probability of winning the second game? Having lost the first game, so lose and then win. 3 over 8 and then 2 over 9. Now, the only thing you need to remember is you're multiplying these. The probability shouldn't increase. When you're trying to be really specific, so I'm saying she loses the first game, then wins the second. That's specific, which means it's less likely to happen. Right? It's not just what's the probability she loses and wins. No, it's loses and then wins, okay? Same thing for the second one. What's the probability of winning then losing? Well, it's winning then losing, so it's 5 out of 8 times 7 out of 9. And then losing both games, 3 out of 8, 7 over 9. We're not done yet. Now, again, just from the mark scheme, for one correct product, so for any of these, we get 1 mark. Now, for the next mark, we need to do a full method, in air quotes, which means we need to work these out and then do something with them. So 3 times 2 is 6, 9 times 8 is 72. I'm not going to simplify, because if you notice, all of our denominators are 72. So if we keep them all 72, it makes our life a bit easier. 5 times 7 is 35. And then 3 times 7 is 21. That's 1 mark. But the second mark is for adding them all up. Now, why are we adding them up? This is because, as we mentioned, there's 3 timelines, 3 universes where we satisfy this, right? Universe 1, where we lose then win. Universe 2, where she wins then loses. Universe 3, where she loses and loses. Okay? So, we can add them all up because it's 3 possible ways it happens. If there's only one way that it can ever happen, we wouldn't have to add anything up. It's less likely, right? Again, think of Infinity War, Doctor Strange, right? Only 1 timeline where they win. In this case, we have 3 timelines, so it's more likely to win, right? More likely to succeed. So if we add that all up, 6 plus 35 is 41. Add 21 is 62. Yes. Out of 72. And that's exactly why I didn't simplify the fractions, because I can add them up really nice and easily. For the third mark. Nice and easy, hopefully. Y is directly proportional to x. Y is 24 when x is 1.5. Work at the value of y when x is 5. Some students try and do this using kind of guesswork and a calculator or something. Obviously, this is a non-calculator paper, which does sometimes work and you get the marks for it, but the method marks, in my opinion, are really, really generous. So the y is directly proportional to x, so we can write y equals kx. 1 mark straight away, which is nice. The second mark is for working out what k is. K is just a constant, and we can work it out using this information here. So y is 24 when x is 1.5, so 24 equals 1.5 k. So k is equal to 24 over 1.5. We're probably going to have to do some fancy division, or I'm pretty sure it's 16. You know what? Let's actually do the division. Let's times the top and bottom by 10. So we've got 240 over 15. And now we can actually simplify it. So divide top and bottom by 5, which gives me 48. Does it? 48 over... Actually, you know what? Divide it by 3. That makes more sense, doesn't it? So divided by 3, we can get 80 over 5, which is 16. There we go. That was an easier way to do it. Cool. That gives you the second mark. So now we have y is equal to 16x, and then all we need to do is sub in x is 5. So again, showing your work really is worthwhile, because you can get 80 without that, but what if you get it wrong and you get 0? Instead, if you follow the steps, you get 3 marks for honestly quite a generous question. Okie dokie, so we need to write 1 over 16 in the form 4 to the power of n, where n is an integer. So the first thing I would do is looking at that 16, how can you write 16 in terms of a power of 4? And the answer is by writing 1 over 4 squared, right? Because 4 times 4 is 16. But they want 4 to be not in a fraction, right? They want to bring it up. Now, if you remember, to flip any fraction, you need to make it negative. So it's 4 to the minus 2. And for this one, again, all we would need to do is work out each of these. Now, I always do the denominator first. Now, the denominator tells you what root you're taking. So this basically means the cube root of 8 to the power of 5 minus the square root of 9 to the power of 3. So let's do it in steps. So first of all, cube root of 8 is 2, so we have 2 to the power of 5 minus 3 to the power of 3. Now 2 to the power of 5, so that's 2 times 2 is 4, 8, 16, 32. You're just doubling every time. Quite nice to work out. Minus 3, that's actually meant to be a cubed. It was a cube, but I didn't like it. Minus 27, so the answer is just 5. For 3 marks. Pretty good. So again, you get a mark for the first line, second line, and then third line. So really quite simple in terms of marking. This question is really interesting, because when it says you must show all your working, I want to read this directly from the mark scheme. A correct answer with no supportive working gets 0 marks. So yeah, their reasoning is, again, because when you're doing an exam, it's not a test to see if you can get the right answers, it's a test to see if you know how to do the questions, which is why you only get 1 mark for the answer, right? If you've noticed, almost every question we've done today has been more than 1 mark. So you actually get the least amount of marks for the answer, which is fairly interesting, right? I know that seems a bit annoying, but people make mistakes, right? You get the slightly the wrong answer, but your method's correct. You can still get 75% or 80% or something crazy like that. So the equation of the line is y equals 2x minus 5. The equation of line L2 is 6y plus kx minus 12 is 0. L1 and L2 are perpendicular. So what does that mean? It means that their gradients, they multiply to minus 1, or they are negative reciprocals of each other, depending on how you want to do it. So what's the gradient of this? The gradient of this is 2, right? The number in front of x is just the gradient, which only works if it's in the form y equals mx plus c, which means the gradient of this line should be the negative reciprocal. It should be minus 1 over 2. Okay, now that doesn't mean that k is equal to minus 1 over 2, because if you look at the form this equation's written in, it's not written in y equals mx plus c. So that's our first job. Our first job is to write this in terms of y equals mx plus c. So first things first, I'm going to move the kx and the 12 to the other side. So we get 6y equals minus kx plus 12. Divide both sides by 6. So minus k over 6 x plus 2. Okay, so what's the gradient of this line? The gradient of this line is minus k over 6. But we know that it should equal minus a half, right? Now we're just solving the equation. Times both sides by 6. We get minus k equals minus a half of 6 technically, or minus 6 over 2, however you want to work it out. So if minus k is equal to minus 3, that means k is equal to 3. Not too bad. Not too bad. Here's the sphere. 3/8 of the surface area of the sphere is 75 pi. Find the diameter of the sphere. Give your answer in the form a root b, where a is an integer and b is a prime number. Don't forget with the whole prime number thing, when you simplify surds, your end answer is always a prime number anyway. So who cares, right? Like, it doesn't really make a difference. Now, how do you approach this? Again, for me, these questions are they're not mathematically challenging, it's just the problem-solving element. So there's a lot of words here, right? But they say 3/8 of the surface area of the sphere is 75 pi. So if I write surface area of the sphere, that's 4 pi r squared. They're saying 3/8 of 4 pi r squared, so if I add 3/8 to the front, 3/8 of this should equal 75 pi. Now, how many unknowns do I have in this expression, in this equation? 1, I have r. Now, they want me to find the diameter, which is just 2 times r, right? So they're just asking me to find 2r. And now from here, it's nice and easy. But again, students don't always write stuff out. They don't always kind of see what's going on fully. So just be careful with that. So again, what I'm going to do is I'm going to divide both sides by pi, because then we don't have any pi's, which is nice. 3/8 of 4. Well, if I times the top by 4, so that's 12 over 8, which is divided by 4, 3 over 4. 4 over 3, sorry. Actually, no, let's do it in 2 steps, because that would be nicer. Equals 75. 75. Then if we simplify this, we can divide top and bottom by 4, so we get 3 over 2 r squared equals 75. Divide both sides by 3, we get a half r squared equals 25. Times by 2, we get r squared equals 50, which means r is equal to the square root of 50. So we need to simplify the surd to get it in the form a root b. So I'm going to do that as 25 and 2. So that's 5 root 2. But remember, we're looking for the diameter, which is 2 times r. So the diameter is equal to 2 times 5 root 2. So it's just 10 root 2. So again, not too bad once you actually write out the equation. A common mistake is putting the 3/8 on the other side, so putting it where the 75 is instead of putting it on the side where there's 4 pi r squared. And yeah, again, it's just forming the equation. A lot of students get stuck on the very first part. That's 4 marks, and I think that is fairly decent in terms of a question. Questions like this, making x the subject, this is also not always answered very well, especially because there are 2 x's. If there are 2 x's in an equation, we want them on the same side. But Mitchell, they are on the same side. True. When I say on the same side, I also mean we want there to be no fractions, because that's a bit tricky. So the first thing I do, because I hate fractions, and I get violently ill when I see them, is I'm going to times both sides by the denominator. So I get y, 5x plus 3 equals 4, 2x minus 7. And now, because we want to make x the subject of the formula, we're going to bring everything with x to one side. So the first thing I need to do is I need to actually expand the brackets. 3y equals 8x minus 28. Now, which side do I want to put the x on? Now, this, by the way, this is something quite important. With this question, there are going to be 2 right answers, because I can either move the x to the left side or the x to the right side. Both answers are different, but they are actually the same if you simplify them. So you get marks for both of them. I'm going to move the x's to the right hand side. So I'm going to add 28 to both sides. So I'm going to move the 28 to this side and the 5xy to this side. So if I add 28 to both sides, I get 28 plus 3y. And I've minused 5xy from both sides, so we get 8x minus 5xy. Now again, we want x equals, that's what x the subject means. It means make it x equals. So we're going to factorize out the x now, because we have 2 lots of x. How do I make it 1x? We factorize out the x. So 28 plus 3y equals x 8 minus 5y. Now divide both sides by 8 minus 5y, we get 28 plus 3y over 8 minus 5y equals x. The other answer to this is if you swap the signs of everything here, so you have minus 28 minus 3y over minus 8 plus 5y, that's also correct. And that's if you move the x's to the to the left hand side instead of the right hand side. But again, it's the same answer, you get marks for it. It's in the mark scheme, both solutions, that should be fine. Combining ratios and basically the first line in this question is a bit evil. This is tricky, and there are loads of ways to do it, and some students did things right, some students did things wrong. It was a bit of a mess, I'm not going to lie to you. Now some students, they tried to make this as like 7 kilograms of carrots, so they wrote 7c plus 5t equals 480, and funnily enough that does give you a mark, but the thing is you get stuck now, don't you? From here it then says the cost of 1 kilograms of carrots to 1 kilograms of tomatoes is 5 to 9. Now the way I like to do this is instead, I don't know how much one part is worth, right? So there's 5 parts for the cost of carrots and there's 9 parts for the cost of tomatoes. I don't know how much one part is worth. So I would like to write this as 5 times x to 9x, where x is what one part is worth. And then I can write this equation as 5x plus 9x equals 480. Well, what I need to do here is I need to times this one by 7 and this one by 5, right? Because this only works for 1 kilogram and 1 kilogram. So if I times the first one by 7, we get 35x. In fact, maybe I should have written this. So basically we're doing this. Plus 5 times 9x, right? Because again, this is 5 kilograms of tomatoes. 1 kilogram is 9x. So we get 35x for the 7 kilograms of carrots, and then 45x for the 5 kilograms of tomatoes equals 480. Okay, and again, I think this makes things a little bit easier when it comes to this. 35 plus 45 is 80, so we have 80x equals 480. So just as a quick recap, we have 7 kilograms of tomatoes, 5 kilograms of 7 kilograms of carrots, 5 kilograms of tomatoes is 480p. But we worked out that 1 kilogram of carrots is equal to 5x. So I've subbed that in. And 1 kilogram of tomatoes is 9x, sub that in. Now if I divide both sides by 10, so we get 8x equals 48, which means x equals 6. So one part is 6 pence. So if I want to work out the cost of 1 kilogram of carrots, well, 1 kilogram of carrots is 5x. So 5 times 6 is 30p for a kilogram of carrots. 9 times 6 is 54p for a kilogram of tomatoes. And I think that's the best way to do it, in my opinion. Write this first equation and then substitute this in. Solving this by itself is a little tricky. People try to use like trial and error, for example, which just took them a really long time unless they got lucky. This is a question about product rule for counting. The menu in a restaurant has starters, main courses and desserts. So starters. There are 5 different starters you can pick from. There are 12 main courses and there are X desserts. There are 420 different ways to choose a starter, main course and dessert. So that means if I times these 3 things together, 5 times 12 times X, I should get 420. And again, I like doing it in this way because it really does illustrate how the product rule for counting works. Because for example, for every starter, there are 12 main courses. So if there are 5 starters, there are 5 times 12 combinations, right? Because starter 1 has 12 possibilities, starter 2 has 12 possibilities, so that's 24. Starter 3 has 12 possibilities, 36, and so on. So that means 60x equals 420. Again, divide by that. So if 6x equals 42, which means x would have to equal 7. There are 7 different desserts to choose from. Hopefully that makes sense with the product rule for counting. I like to use boxes and write the numbers in them. I have got a product rule for counting video if you're unsure. Functions, again, everyone's favourite topic. I always say that sarcastically, and honestly, yeah, functions kind of suck. It's anywhere from grade 7 to grade 9, depending on the question. So that's really, really fun, isn't it? Now, finding the inverse function, everyone has a slightly different method. The way I like to do it is I'm basically rearranging the g of x function for x. So I like to write it like this. And then I'm making x the subject. So times both sides by 5. Minus 2. Square both sides. And I do not need to expand the brackets. You can if you want to. But that's my equation. Now all I need to do is, because the way functions are written, we write them where x is the variable, not y. I just need to change that to 5x minus 2 squared. Because again, remember, when we name something x or y, it is arbitrary. It doesn't really make a difference which way around it is. I could call that m or n or u or z, whatever I want to. Now solving this, g f of x equals 3, is a bit interesting. This g f of x means we are taking the function f of x and substituting it in as x in g of x. So here's how I do it. Is g f of x, I write it like this. I write square root. Wherever the x is, I just leave a big gap. And then all I'm doing is wherever x was, I'm writing the entire function of x, which is 3x plus 4. And that should equal, it says 3. And I'm just solving it. So times both sides by 5. I get root 3x plus 4 plus 2 equals 15. Minus 2 from both sides. Root 3x plus 4 equals 13. Square both sides. 3x plus 4 is 169. Minus 4 divided by 3. What is that divided by 3? That would have to be 55, wouldn't it? Yeah. By the way, you can just use bus-stop method. I don't know why I'm making my life harder by not using it. But yeah, 55. Not too bad, hopefully. But again, knowing this notation is something that some students make mistakes on. Okay, circle theorem question. Circle theorems a lot of people really, really dislike, which is honestly fair enough. But with a lot of practice comes being able to recognize these by sight, which is very useful. And just using the information. So CD is the tangent to the circle. Now OD is also the radius. Now the first thing I would do though here is, it says work out the size of the angle ADC. So that's this angle here. Then I'd start labeling anything I know. Well, O to D is of course the radius. And we know that CD is a tangent, which means this entire angle is 90 degrees. So that gives me an idea of where I can start. By the way, if I write that ODC equals 90 degrees because radii meet tangents at 90 degrees, that's given me marks already, right? Even though I might not necessarily know what I'm doing. I mean, I do, obviously. But even if I don't necessarily know what I'm doing, I'm still getting marks, even if I haven't got the answer yet, which is beautiful, right? And this is a 4-mark question. Now, this kind of leads me on to maybe perhaps a theory that if I work out what this angle is, somehow, I could then just do 90 minus the green angle to work out the blue angle, which is the one we want. So this makes a triangle, this O to this point to this point. So let's see if we can work something out. Well, the other thing that kind of sticks out to me is this 64 and this angle. It looks like there should be something relating them, right? It looks like there should be something. Either they're the same or perhaps something else. Now, my first thought is, oh, they're the same because angles in the same segment. But the problem is one of these is at the center of the circle and one of them is at the circumference. So maybe that's triggered something in your head. Angles at the center are twice the angles at the circumference. So that would be 32 degrees, right? Now, why does that work? It's because if you notice, these angles, BOD and BAD, are made up from the same points on the circumference. They're both made up from the points B and D, right? If I draw lines going from them. So that means they're made up, it's either angles in the same segment or alternate segments, or it's angles in the center and the circle. In this case, because one of them's at the center and one of them is at the circumference, that means the one at the circumference is half the one at the center. Again, you should write this out to actually get the full marks. Now I can work out this angle though, right? Because angles in a triangle. So 51 plus 32 is 83. Then 180 minus 83 gives me 97. So that blue angle there is 97. That means that one's also 97 because it's vertically opposite angles. Now I can work out the green angle by doing 97 plus 64. So let's do 7 plus 4 is, so that make it 71. So that'd be 161, which means the green angle is 180 minus 161, which is 19, which means the final angle ADC, which is what they're asking us for. So it's not 180. 90 minus 19, which is 71 degrees. Now in terms of the other circle theorems, we also use the angles at the center are twice the angles of circumference, and that's actually it. So we only need to write that one other statement and we'll get the full 4 marks, which is nice. 3D trigonometry and or Pythagoras, I don't know yet because I haven't read the full question. Again, something that a lot of students worry about, and it is very difficult to visualize, so I fully understand. So hopefully I'm going to show you some tricks here which make it a bit easier for you to visualize. So this is a cuboid and it gives us some lengths. Work out the size of the angle between FC and the plane ABCD. Now a plane is just the flat part, so this is basically the angle between FC and the bottom of this cuboid. So the first thing I do is I actually draw on FC, and that there is my angle that I'm working out. Cool. The next thing I do is I label all of the information they've given me. So AF is 6.8 and FC is 13.6. You know what? This is even easier than I thought. Normally in these questions, you have to do 2 steps, which gives you 4 marks. So you have to use 2 different triangles. But for this one, have a look at what they've given us. If I finish this off for a second, now the topics are called Pythagoras and trigonometry, which means it's a right angle triangle. So if I just finish off this triangle, can you see how this gives me a right angle triangle? In fact, let me draw this out for you. That's F, C, and A. That's the angle I want. They've given me 6.8 and 13.6. Look at that. How nice is that? It's literally just normal trigonometry. Again, normally they give you something that's a bit more complicated than this, but all we need to do now is use trig. So that's my opposite side, that's my hypotenuse, so we're using sine. So we have sine theta equals 6.8 over 13.6. Now remember, this is a non-calculator paper, so I'm going to simplify this. That is a half, right? Because 6.8 goes into 13.6. And now here's the tricky bit, right? Sine of what angle gives us a half? Remember, there are angles we need to remember. We need to know what sine 0, 30, 45, 60 and 90 are. We need to know it for cos and tan as well. I am planning on making a video, just a very quick 2-minute video on how I remember it, which is drawing out a table, which I quite like. But the answer to that is it's sine 30 that gives us a half. Very quick 2-mark question, not too bad. Well, this question is disgusting. So we have to basically combine these 2 fractions in the form this, where a, b and c are integers. So there's a few things to this. There's going to be simplifying surds, I'm willing to bet, and because there's surds in the question. And before we do this, we can't actually make the denominators the same yet. I can't make 4 minus root 3 into root 3, and vice versa. By the way, if you try and add 4 to both top and bottom, that doesn't work. When you change a fraction, you can only multiply or divide. So what we're going to have to do first is rationalize both of these fractions. Yay. Which means the first one we have to times top and bottom by 4 plus root 3. So let's fill that in. Top and bottom. And that's 4 minus root 3, bracket, 4 plus root 3. And the other one we're going to times by just root 3, which is quite nice. In fact, I'm just going to write over 3 because we know it's going to happen. Cool, now we expand. So 3 root 3 times 4 is 12 root 3. Then we have, when I do this, I do this in a bit of a different way. I do this as 3 root 9, and then I know that when I square root it's going to be 3, so 3 times 3. The reason why I do this is I see a lot of students, especially in the non-calculator paper, they'll do 3 root 3 times root 3, and they'll end up trying to do it in their head, So then they're like, okay, so it's 3 times root 9, so 3 times 3, which is 9, or whatever. Especially when the number's a bit bigger. Like if it's 14 root 5 times root 5, they make mistakes. So instead, I do it in 2 steps. Bear in mind, this isn't actually any more work because I'm still going to do an extra step after this anyway. So regardless, it's the same thing. 4 times 4 is 16. Now I know I'm going to get plus 4 root 3 and minus 4 root 3, so I'm not even going to write them. Then it's minus root 3 times root 3. That one, it's okay to skip the step. I can just write minus 3 because it's just one thing. But if there's a number in front of it, I do recommend doing it in 2 steps. So now let's do this. So it's going to be 12 root 3 plus 9 over 13 minus 2 root 3 over 3. Now I need to combine them, so I need to times them by each other. So I'm going to times the first one top and bottom by 3, second one top and bottom by 13. So 3 times 12 root 3 is 36 root 3. 3 times 9 is 27. 13 times 3 is 39. Minus, that would be 26 root 3 over 39. Now I can subtract them. So 36 root 3 minus 26 root 3 is just 13 root 3. That's just plus 27 again. Over 39. And does it say... It doesn't say I have to simplify, which is interesting. Because I can... I mean, okay, we can't do that in this case anyway. But I was just checking for other questions as well. You don't normally have to simplify even if you can. But yeah, that would be it for that question. So not too bad, but again, some tips. I would try and not do anything in my head. Because when you do things in your head, you tend to make mistakes. Or you can make mistakes, right? It increases the likelihood. And I absolutely love this question because this kind of question... The students that can do this well, it indicates to me that they can do A-level maths. I know that sounds a bit extreme, but the reason why I really, really, really like this is because there's a few little tricks here which show that you really understand maths. And you only can do the tricks if you really understand the maths. So, a lot of GCSE students, they end up learning a process. And maths, okay, it has processes in it, but for this, again, you will not get the full 5 marks unless you can really understand what the maths is. Now, find the set of possible values of x for which these 2 inequalities are true. The first thing I'm going to do, this is disgusting because it's negative, so I'm going to move everything to the other side. Now, to do this, we need to solve these inequalities separately and then combine them together. So if I start with the 4x squared minus 25 is less than 0. Now, again, I do not like the way a lot of people learn this because I don't think it illustrates what's happening. All we're trying to do, if I read this, is the graph of 4x squared minus 25, I'm finding the values for which it's below 0. So what you're actually doing in this question is you're sketching a graph. That's it. But again, people try to think of it as something separate to graph sketching. It's not. So if I asked you to sketch the graph of 4x squared minus 25, what would you do? Well, if I think about it, you would have to work out the x-intercepts. So you'd work out where this graph equals 0. Okay? So some people, they learn the process, they just do this and they don't understand why. Remember, all we're doing here is we're going to sketch both of these graphs and we're going to look for the values for which this graph is less than 0 and this graph is less than 0 as well. So, that's just difference of 2 squares, so that's just 2x minus 5, 2x plus 5 is equal to 0, which means you either have x is 2.5, right, 5 over 2, or x equals minus 2.5. So our 2 solutions over here are 2 roots, 2.5 and minus 2.5. And now if I sketch the graph, is there a happy or a sad face? Well, because it's a positive x squared, it's a nice, big, happy face, symmetrical about the origin. Now, if I asked you, again, forget about maths for a second. If I asked you, where on this graph is the graph below 0, hopefully you would point out this area here. Why? Well, it's because the y-coordinate is less than 0. It's negative. Okay? So, again, at these 2 points, it equals 0 because it's along the x-axis. Between those 2 points, it goes below the x-axis. So the y-coordinate is negative. This here is just the y-coordinate, right? Y equals all of this. So if I read the question again, it's saying, when is the y-coordinate of this graph less than 0? Well, the answer to that is between the values of minus 2.5 and plus 2.5, because that's where it dips below the x-axis. Now, if you notice, I haven't put equals to, because the graph says, the question says less than 0. It doesn't say less than equal to 0. When it's at minus 2.5 or 2.5, it equals 0. So that's the key difference. Now all we need to do is repeat that same process for this graph and then try and combine them. So again, if I asked you, okay, how do I sketch that 3x squared graph? Well, again, we need to factorize it, right? We need to work out when it equals 0. And that happens when, well, we need to find two numbers that times to minus 36, because again, 3 times negative 12 is negative 36, and it adds to 5. So that would be, let's have a think, shall we? 1 is negative, 1 is positive. The positive number has to be bigger. So 12 and 3, that's too big. What else? 6 and 6, that's not good enough. Let's have a think. What other factors are there? There's 9 and 4, so it'd be 9 and minus 4. Okay, so we have, if I write this, oh god, I have not left myself some space, it's right on the side. So we have 3x squared, okay, thanks Microsoft, plus 9x, the bigger one has to be positive because the 5x is positive. Again, this still simplifies to that, so it's right. Then we factorize the first term, factorize the second term. Again, both of these brackets should be the same, and we get 3x minus 4 and x plus 3. And again, that equals 0. So we either have x is 4 over 3, 1.3 recurring, or it's minus 3. So we have minus 3 over here, and we have 4 over 3 over here. And again, it's a happy face because it's a positive x squared graph. And again, if I asked you, where on this graph is it below 0? Well, here it's above 0, then it goes below 0, then above 0 again. So again, it's between those two values. So it's between minus 3. I want to write 1.3 recurring just for now because it makes the next part easier. Now, it says, and. So what set of values do we have where both of these are true? Now, if you find this a little bit tricky, I would recommend drawing a number line. I know number lines seem childish, but I even get sixth formers to do this because it really is the easiest way to think about what values we're looking at. So if I plot this inequality first, we have minus 2.5 up to positive 2.5. Right, that's the first inequality. And this one is minus 3 up to 1.3 just over here. Now, we're looking for the overlap between these. When are they both true? Well, they're both true when this is minus 2.5 and this is 1.3 recurring. So it's true between the values of minus 2.5 and 1.3 recurring. That is my final answer. Hopefully that isn't too bad. Again, when you sketch this and you really draw it out and you visualize things, it makes the whole question a lot easier. Now, I'm going to link this back to what I said before about if you can do questions like this with confidence, so not that you're memorizing a process, trying to think, oh, what's the next step in the process? Instead, you're actually understanding why we're doing each step, then you are ready for A-level math. Not just ready for it, by the way. I'm talking about A star level at A-level maths. It's still going to be a lot of work, but it means your thought processes, your problem solving is to a level where you can get an A or an A star. If this is a bit confusing to you, it doesn't mean you can't do A-level maths. It just means it's going to take a lot more work to develop the problem solving skills that you need. This is all problem solving. And again, hopefully this last part with the number line, which is how I've taught it on my channel before, hopefully it makes more sense now as to why you're doing certain things. I've heard teachers say this, where it's just, oh, you take the lower bit of this one and the bigger one of this one. What? Not always. Not always. I've seen answers to questions where it's literally just the right-hand one. As in, the other one has no values. It is literally just this one. So you can't just say that, okay? It's very, very specific. If you found this video useful at all, please do consider subscribing because it really does help me. In the description, there's a link to my email and my website as well if you're interested in tuition or getting in touch with me for suggestions or questions or anything like that. Have a really wonderful day, and I'll see you in the next one.